Another exam question walkthrough for the bonding and structure topic. So we're up to number 11 now. If you want to check out the other videos in the playlist, I'll put the link to that at the top of the screen now. Hope you like the video, hope you find it helpful, and if you haven't already subscribed to the channel, I would love you to do so, but as always, the link to the questions in the description of the video if you want to try it first. Okay, so make a start. So questions all about the different types of bonding. So first part of A, what is meant by ionic bonding? It's the electrostatic attraction between oppositely charged ions. Whatever you do, do not say the bonding between a metal and a non-metal. Moving on to the next part, so we're told magnesium reacts with sulfur to form a compound with a giant ionic lattice structure. So obviously the compound in question is going to be magnesium sulfide, not magnesium sulfate. That would be a very common mistake. Sulfate has oxygen as well as the sulfur. So the formula is MgS. It contains the Mg2 plus ion and the S2 minus ion. So you can see I've put an Mg2 plus ion in that corner there. So that means I need S2 minus directly next to that. Okay, so as long as they're alternating, that's fine. Moving on to part B, so we've got some information about oxyanions. We've got to give the name for this one here. So we've got bromine and oxygen, so it's going to be bromate. And the only other thing we've got to do is work out the oxidation number of the bromine, and obviously express that as a Roman numeral. So we've got two oxygens, each of those will have an oxidation number of -2. So to be left with the overall 1 minus charge for the ion, the bromine needs to be +3, which means we need the Roman numeral 3 there, so bromate 3. Moving on to the third one, so phosphate 5 obviously is going to contain phosphorus and oxygen. The Roman 5 there is telling us the oxidation number of phosphorus is +5, and we've got the total ionic charge of 3 minus. So remember, oxygen's got an oxidation number of -2. So how many of these do we need to be left with the 3 minus charge when we've got +5 for the phosphorus? So obviously we need a -8 total from the oxygen to leave the -3. So we're going to need 4 oxygens. So it's PO4, and obviously 3 minus charge. And finally, part C, you've got to describe the structure and bonding and electrical conductivity of calcium in the solid state, and we can include a label diagram if we want. I would strongly encourage you to do so. So in terms of a diagram, we just need to draw a typical diagram for metallic bonding. I always draw 3 rows of 3 metal cations. So obviously, because it's calcium, it's Ca2 plus in there, and then we've got dotted around some delocalized electrons. So all we'll do now is just work our way through the question. So describe the structure. The structure is a giant metallic lattice. Moving on to the bonding, it's metallic bonding. So that's the electrostatic attraction between Ca2 plus ions and delocalized electrons. And electrical conductivity, well, calcium conducts in the solid state, as do all metals, and that's because the delocalized electrons can move through the structure and carry the charge.